All right, welcome back to The Explainer. Today, we're jumping into something that's, well, it's pretty much the most important job in modern AI, even if you haven't heard of it: context engineering. So if you're out there building with AI agents, or you're just totally fascinated by how they actually work under the hood, you're going to want to stick around for this. Okay, so to really wrap our heads around this, we need a good analogy. And this one is perfect. I want you to think of an LLM, a large language model, as the CPU of a computer. It's the brain, right? The powerhouse doing all the thinking. But, and this is so important, its context window is like RAM. You know, it's short-term working memory. And here's the catch. That RAM is tiny. It's incredibly small, and it fills up fast.
You know the AI legend Andrej Karpathy? He just nails it. He calls context engineering the delicate art and science of filling the context window with just the right information. And that just perfectly sums up the whole challenge, doesn't it? It's not about just jamming more data in there. It's this delicate dance, this science of managing that tiny, precious RAM to get the AI to do what you want.
Okay, so if that RAM is so valuable, what actually happens when it gets too full? This is where we hit the real crisis. The core problem, especially for these complex AI agents everyone's building now.
The agents are a special kind of problem. They have these two big habits that just devour context. First, you've got them tackling these long, complicated, multi-step tasks. And second, they're constantly reaching for tools, calling APIs, searching the web, using a calculator. Every single one of those actions adds more stuff back into that already cramped working memory.
And you can totally see how this spirals out of control, right? A user asks something, the agent calls tool A, shoves the result into its memory. Then it calls tool B and shoves that in there too. And with every step, the context just gets messier and messier, a confusing jumble of old and new information. And what happens? The agent gets lost. It makes a mistake. Its working memory is just completely swamped. And look, this isn't just some abstract idea. When a context gets too crowded, it leads to these really specific, predictable types of failures. You get context poisoning, where one piece of bad information just ruins the whole process. There's distraction, where irrelevant data sends the AI off on a total wild goose chase. You get curation failure, where the right answer is in there somewhere, but the AI just can't find it. And clash, where it gets conflicting instructions and just freezes. And that is where context engineering steps in as the hero. Let's go back to our computer analogy. If the LLM is the CPU, the context engineer is the person designing the operating system, you know, the software that manages the RAM. It's an absolutely crucial job if we want to build AI that's actually reliable and advanced.
So the big question is, how do they actually do this? What does it look like to build that operating system for an AI's brain? Well, it really boils down to a toolkit of 4 main strategies.
And what's cool is that all 4 of these strategies tie right back into that computer analogy we've been using. You've got writing, which is basically saving something to a hard drive. Then there's selecting, which is like opening just the right file you need. Compressing, that's like zipping up a file to make it smaller. And finally, isolating, which is like running a virtual machine to keep tasks from messing with each other. Let's break them down. All right, first up is rating. And this one is probably the easiest one to grasp. It's literally just saving information outside of the AI's active memory for later. I mean, it's what we do as humans, right? You take notes, you save a file, so you don't have to juggle everything in your head at once. And in the world of AI, this usually shows up in 2 ways. For quick, in-the-moment stuff, an agent uses a scratch pad. Think of it as a temporary note. But for knowledge that needs to stick around, maybe for the next time you talk to it, it uses memories. So it's really the difference between a throwaway sticky note and a permanent entry in a journal. Okay, strategy number 2, selecting. This is the perfect follow-up to writing. I mean, once you've saved all this stuff to your external hard drive, you've got to have a smart way to bring it back, right? You can't just dump it all back in. So selecting is the fine art of choosing only the specific pieces of info you need to pull back into that tiny context window for the job you're doing right now. And this is where it gets really interesting and maybe a little counterintuitive. You think, hey, let's give the AI more tools. More is better. But look at this. the data shows the complete opposite. When an agent has just a few tools, say Ken, its success rate is sky high. But as you give it more and more tools to choose from, its performance just tanks. It's classic choice paralysis. Give it 100 options and it gets lost and can't figure out what to do.
So, what kind of stuff are we talking about selecting? Well, it could be finding the most relevant tools for a task, often using a search method like RAG. Or it could be pulling key facts from a huge knowledge base. It could even be pulling in specific instructions or a style guide for how to respond. The goal is always the same. Only load what's absolutely essential into that precious, limited RAM.
Strategy number 3 is compressing. This one is all about efficiency. How can we make the information that is in the context window take up less space? It's about boiling things down, keeping only the most important bits from a long conversation or a document to cut down on the clutter. The perfect analogy is creating a summary or zipping a huge folder of files into a tiny package.
And engineers do this in a couple of clever ways. The first is summarization. The system literally creates a shorter version of a long piece of text or the output from a tool. The second is trimming. This is a smart way to snip out the less important parts of a conversation, like maybe the first few messages from a long chat that aren't really relevant anymore.
And that brings us to our fourth and final strategy, isolating. Now, this one's a bit different. Instead of trying to clean up one massive, messy context window, the idea here is, why not just create several small, clean ones? It's a really clever trick where you split a big, complex problem into smaller chunks, and you give each chunk its own pristine workspace. That way, different parts of the problem can't interfere with each other.
So what does this look like in the real world? Well, you often see it in multi-agent systems. Imagine a whole team of little specialist AIs, all working on their piece of the puzzle in parallel, each with its own clean context. Another way is through sandboxing. This is where you run a piece of code in a separate, safe bubble. It does its thing, figures out the answer, and then just passes that clean, final result back to the main AI, without flooding its memory with all the messy steps it took to get there. Okay, so let's pull back for a second. We've seen the memory problem, and we've walked through the engineer's 4-part toolkit for solving it. But let's zoom out to the big picture, because this isn't just a clever trick. This is fundamental to where AI is headed.
And I want to be clear, this is not some weird academic niche. The folks at Cognition AI, the team that built the agent Devin, they put it bluntly. They said context engineering is effectively the #1 job of engineers building AI agents. The #1 job. When you hear that from a team on the cutting edge, you know this is absolutely central to making AI work in the real world. And really, all of this just brings us right back to where we started, to that core analogy. As we keep building more and more powerful AI, it really makes you wonder, doesn't it? Maybe the biggest challenge ahead isn't about building a bigger brain, a more powerful CPU. Maybe the real game is about designing a smarter memory. Perhaps the future of AI isn't about a bigger brain at all, but about finally mastering how it remembers. Thanks for joining me on The Explainer.